We've seen how SwiftUI's environment flows downwards, but sometimes you want information to flow upwards too. Send data back from a child view up to its ancestor views. In SwiftUI, this is done using preferences, and the canonical example is a navigation title modifier. For example, we could write code like this. There's a navigation stack with a vstack inside. I'll do an image inside there with the system name of sun.max, then text of welcome, and then a nav title of my app. Now in this code, it's the navigation, the vstack that owns the navigation title right here, right? That is the thing describing the title that should appear in our navigation stack. And this makes sense from a UI perspective because, of course, the nav stack can push and pop views freely and needs to be able to update its title based on the view it's currently showing. So the vstack's what it's showing right now, use its title for the nav stack. That makes sense. Now, just like the environment, preferences flow upwards continuously rather than stopping at the very first ancestor. In our simple content view code here, we could have put this nav title into the text, for example. That also works. Same result. Title flows upwards to the vstack, upwards to the nav stack, boom, it's displayed. Of course, that might set off some alarm bells. What if we had multiple nav titles? Like if we had a nav title here for image, and then one here for text, and another one here for vstack. Which one would be used? As you can see right now, it uses the very first one it finds. It'll show image as its nav title at the top. And this kind of preference system is open to us to use as needed, although please keep in mind, having data flow freely downwards and upwards can easily result in spaghetti code, so be careful. Now, aroma preferences work in a very similar way to this navigation title modifier. Any view can add them, they flow upwards through our views, and we've got to choose one value. So we have this one, or this one, or this one. Nav stack's choosing the first one, we have to also choose. Now, it's not identical because we can go ahead and decide how that single value is selected. Maybe we want to choose the last one, for example, or a random one, whatever you want, down to you. Or maybe we combine values into one super value. Enough talk. Let's give it a try. Let's implement a preference value ourselves that will let a child report its size upwards to its containers. And the first step to doing this is making a new struct that conforms to the preference key protocol. It requires to provide a default value for the preference, just like the way environment key works. But we also have to implement a reducer function, which chooses which value to use when we have several of them to choose from. When we get several, choose one somehow according to the logic of our choosing. In our case, we'll track the width of some view, but if we get multiple widths coming in, we'll just track the last one. So I'll say a struct called width preference key, which is a preference key. In there is the default value of 0.0, and then our reducer function, this thing here, we're going to get the current value in out here, plus the next value. We'll just say value equals next value. Always use whatever comes next again and again and again until there are no more. So our last value is the final value. And now we can make a view that sets a value for that preference. We can say the new struct called sizing view, a view has an @state private var width of 50 by default. And then its body, I'll say is a color.red with a frame width of that width, height of 100. When we tap on this thing, I'll say my width's a new double randomly between the range of 50 through to 160. Then add a preference here for the width preference key, width preference key.self, the value being our current width. So it changes the size of the view whenever it's tapped and sends that upwards, comma here, some accident, sends that upwards in the width preference key. Report that as my width preference upwards to any ancestor that cares. Finally, we're going to place that view somehow and watch for changes in its preferences. This is done using the onPreference change modifier, which runs code of our choosing when some specific preference changes. So we could say in our content view, for example, down here, that we have @state private var width of 0.0. Then inside this navigation stack, I'll get rid of this current code here. I'll place a sizing view instead. We have an onPreference change modifier, like this one here. Let's try it again. Preference change. Thank you. That's not helping at all. OnPreference change for width preference key.self. There we go. That's better. When that changes, given that the new value comes in, we'll just stash it into our width like that. Whenever someone tells me, hey, my width has changed, my preference has changed, just stash it in the width we're storing locally. And we're doing that because we can now put that into our nav title here. We can say the width is \.width. So when some view tells me, hey, my width has changed, stash it away in our local state, reinvoke body, and then change my nav title to be the new nav title. And that code should work well. I can press Command R to run it. It's 50. I can tap on it. And it's randomly changing. And look at the top here. It's telling the exact width of that view every time it changes. Now, of course, rather than displaying the value, we can put it to use somehow. For example, we could use the value to set the width of other unrelated views. We might say, okay, I want to have the sizing view here. Below that, I want a text of 100% with a frame width of that width. So it matches the width of the sizing view in background red. Then below that, I'm going to say we have text of 150%. Let's have a frame width of width times 1.5 in background of green. And then text 200%. And we'll do frame width times 2, background blue. So these unrelated views are taking their size based on the other size at the beginning, that sizing view. So you can see here, they'll grow proportionally as the one above is changing its size. Or we could add multiple views of the same type. Let's get rid of this stuff here and say I want to have 3 sizing views. Like that. Now here, the reducer becomes important. This first one does nothing. Second one does nothing. The third one correctly changed the top bar. Because our reducer always uses the next value again and again and again, ignoring previous values, only stores the final value it's given. And so only the third sizing view changes the title bar at the top. Now, it doesn't have to be that way, right? We can change the way we calculate our reduced value. Up here, this replaces the value of the next value. We could make it sum the values, add them all up by just doing value plus equals next value. So it'll start with 0 and add to it each value that comes along as it goes. So I'll press Command R now, and we should see that our values are total of all the values across the board now, like that. Also works. Even better, you can actually mimic the first preference only approach of navigation title, where only uses the first value and ignores the rest. It takes literally 0 code. Just remove it. Take the first value you get, we're done. And so you'll get now the first one works brilliantly and the rest are ignored, just like the way navigation title works. Now, this happens because it never calls next value. So it means you give me the first value and the next one, but I don't care. Do nothing with them. Stick with the first value.